Here is an explanation for the answer to final exam question number 89, found on page 680 of Teach Yourself Electricity and Electronics 5th edition. The question asks us, with respect to a half-wave dipole antenna, in its favored directions, what is the power gain of an isotropic radiator or isotropic antenna? Now, the dipole's favored directions are perpendicular to the conductor. In this case, it would be actually in a plane perpendicular to this whiteboard. So any direction pointing straight out at us, or up at an angle like that, or straight up, anything perpendicular to the wire is the favored direction of a dipole antenna. The least amount of radiation occurs off of the ends. In fact, theoretically, in free space, for a perfectly straight, perfectly conducting, infinitely thin half-wave dipole antenna, the radiation directly off of the ends would be zero. But you'd get the maximum radiation perpendicular. Now, an isotropic radiator, on the other hand, is a theoretical thing. You can't really build one in practice. There's always a little bit of imperfection. In theory, an isotropic radiator would radiate equally well in all directions in 3 dimensions. And they've actually tried to build those things. They kind of make a irregularly shaped loop. This is a pretty crude representation. But there's no point in even drawing any directional arrows for the isotropic radiator because it's the same in every direction. But the question asks us, what is the difference in power gain between the dipole in its favored directions compared with the isotropic radiator in any of its directions? How does the isotropic radiator compare with the dipole? Well, if we say that this is 0 dBd, now dBd means decibels with respect to a dipole in its favored direction. So 0 means that it's the maximum gain of the dipole in its favored direction. 0 dBd, 0 being the reference level. An isotropic radiator, in all of its favored, well, in all of its directions, favored or not, because there's no such thing as a favorite for this type of antenna, is going to be approximately minus 2.15 dBd. That means that a dipole in its favored direction will have 2.15 decibels of gain over an isotropic radiator in any direction. So the correct answer here, and it's a little bit tricky because we're talking about the gain of an antenna where the signal is weaker. So it's going to be a negative figure, and as it works out in terms of power decibels, it's approximately minus 2.15, which is choice B, as in Bravo.